Hi everyone, welcome back to my AP Calculus class. Today's topic is arc length. This is for only BC only part. Okay, let me explain how to find the arc length using definite integration. Okay, there are three different types of arc length problem. Number one, y equals fx is given. Y equals fx is given, and then x interval will be given. X is greater than or equal to a, and less than or equal to b. And then the length usually use s. S means the length of the curve, right? So find the length s of the curve of y equals fx. The formula is this: integral a to b square root of 1 plus dy over dx squared dx. Okay, these a and b should be x values, right? Because y equals fx is given and x interval is given. In that case, use this formula, right? From a to b, a and b x values, square root of 1 plus dy over dx. You can find the dy over dx, the derivative of fx, using formula, or sometimes implicit differentiation can be used for that. Second type of problem is what? Just x equals gy. So function in terms of y is given, then we're going to find that length s of the arc from y equals c to y equals d. The c and d's y values, right? So y interval is given and then y function is given. And then find that length arc. S equals square root of, integral of c to d. Those two numbers y values. This a and b was x values. This time c and d should be y values and dy. Square root of 1 plus, we use dy over dx squared, right? But what is the derivative of that x equals gy function? The g prime of y, right? That is kind of dx over dy. Because f prime of x means what? That's dy over dx, right? But x equals gy is given, and then you're going to find the g prime of y. Yeah, that derivative function dx over dy. Sometimes you can find the dx over dy using implicit differentiation as well. It's the second type, using x values and dx and x functions derivative. And then you can use y values and dy, and then use derivative of y function dx over dy. The third type is about parametrically defined function. So the third type looks like this. X and y defined by different variable, parametric variable t. So x equals xt, y equals yt. So t is parametric variable, and then we know that interval of t, not x value or y values. That plus t values, right? Interval is given in the t values. And then find that arc length of that parametrically defined function. Use this formula: x equals integral ta to tb, that means two t values, then square root of dx over dt. Dx over dt means what? In the x equals xt function, derivative of that, x prime of t. F prime of t of that function is dx over dt, right? That's dx over dt. And then derivative of yt is y prime t, that represents dy over dt. Use those two derivatives. Square root dx over dt squared plus cy over dt squared. Yeah, I solved three different types example problem from now, okay? Let's start to solve problems. Let's go. Example 13. Example 13, find the length to 3 decimal places of the arc of this function y equals actually 3 over 2 powers from x equals 1 to x equals 8. 2x values given, right? X interval is given 1 to 8. And then we know that x function y equals fx. So which formula? First formula going to be used, right? Integral a to b, 1 square root of 1 plus dy over dx squared, and then dx. So find the dy over dx. dy over dx. Derivative of x function, this function derivative, right? Any any 3 half, so 1 plus n plus 1 times x to the n plus 1. So 2 over 5 x to the 5 over 2. I'm sorry, it is the integral. I have to find derivative. That's my bad. Okay, quickly fix it. Derivative, so 3 over 2 times x to the n minus 1 powers 1 half. Yes, you can use that. Is dy over dx. So by the formula, integral 1 to 8, a to b, square root of 1 plus square of that derivative part. 3 over 2 squared is 9 over 4. And then x to the half powers square is just x. 1 half times 2 is 1. So x dx. If you find that value, that's the answer. If we use the calculator, you can find 22.83803. So it asks you 3 decimal places. So this is the answer. Okay, what about example 14? Example 14 is a little different type of problem. Same question, but you're going to use y value and dy dx over dy instead of dy over dx. I show you how to. Number 1, integral this function, okay, derivative of this function. Let me see. Square root to both sides. So what is x minus 2 equals? Square root to both sides. That means whole things half power, okay? 4 to the half power is 2, and then y to the 3 over 2 powers. So x equals what? 2 times y, 3 over 2 plus 2. I solve this equation for x first. And then find that derivative, right? Of this function, that's going to be dx over dy, not dy over dx. Okay, so dx over dy is equal to 2 times 3 over 2 is 3. So 3, and then y to the n minus 1 half power. And then any number's derivative is 0. So you can find that dx over dy, which is 3y to the half powers. And then use what? Integral. We know the y interval 0 to 1, and then square root of 1 plus dx over dy squared. So this squared is 9y, and dy. If we calculate this using calculator, it will be 2.268. Number 13, I used dy over dx formula, right? Number 14, I used dx over dy formula. Number 15, example 15, I'm going to use dx over dt and dy over dt because parametrically the function defined. So let's go to the last example today. Example 15. The position xy of a particle at time t is given parametrically by x equals t squared and then y equals t cubed over 3 minus t. So third formula says what? Integral ta over tb, but t is given, t is 1 to 2. So integral 1 to 2 square root of dx over dt squared. That means derivative of this function. Okay, derivative of that f of t, f prime of t is dx over dt because this x equals t squared, right? So dx over dt is 2t squared plus dy over dt is derivative of y function. That's going to be t squared minus 1 whole things squared dt. Okay, so simplify that inside 1 to 2. It is 4t squared plus t to the fourth minus 2t squared plus 1 dt. So it is integral 1 to 2 square root of, if you simplify all these things, gonna be t squared plus 1 squared, right? dt. And square and square to cancel out. Cancel out. Let's come back here. So that means integral 1 to 2 t squared plus 1 dt. We can find the integral of this part, right? So n is 2, so 1/3 t cubed plus t from 1 to 2. Plug in top number, and minus plug in bottom number. Okay, so 8/3 plus 2 minus 1/3 plus 1. It is 7/3 plus 1. So your final answer is what? 10/3. This is the final answer. These are arc lengths of this parametrically defined function. I explained how to find the arc length is only BC part with 3 different examples. Okay, thank you so much for watching my video, and please click subscribe and like, turn on notification. It helps me a lot. Thank you again. Bye bye.